Hello everyone, N3FJZ here, and this is a follow-up to the ZX-SSB-II Front Panel program. And as you can see, I've completed the new proto board layout. And so now it's a duplicate of the original that I have up here. And what I'm going to do in this video is download the code from my website, assemble it, make sure it all works, and go from there. Okay. So we'll start out searching for my website, which is Circuit6040. And this is the site here, and I'm going to go to ZX-SSB-II under projects, and then I'm going to navigate down to the module 110 front panel. And that brings up the schematic of the front panel, and at the top here, and this may change, is a ZX-SSB-II Front Panel software for Arduino Mega 2560. If I click that, it takes me to my software download page. And on the page there's instructions on how to load the library for the Arduino. I happen to be using, I think it's version 1.8, I'm not sure, of the IDE, but we'll get to that. And up here at the top are the links. The topmost link simply just displays the text of the Arduino code, and the next two links will actually allow you to download the actual files. So, in the instructions, it says I need to create 2 folders. Well, you can read the instructions. I'm not going to bore you with the details, but I want to go ahead in the background here and go ahead and do those steps, and go ahead and compile the software. Okay, I've downloaded the Arduino source code and the actual library files per my instructions on the page, and as you can see, we'll have an INO file, which is the source code for the Arduino, and the library file. Okay, and I have my board ready to go. So what I'll do here is connect a USB cable to the Arduino Mega, and if I remember correctly, this should have the I did have the Blink program there. There we go. And so we just got the basic Blink program loaded into the Arduino Mega, and right now there's nothing going on the display. Okay, so if we launch the Arduino IDE, and this is version 1.812, which was the most recent as of May the 8th, 2020, and there's the front panel code loaded. I haven't yet installed the libraries, and just to verify that, I'm going to go and assemble it or compile it, and it comes back with a number of errors, one of which is that it can't find the one of the library files, the header file for one of the code sections. So, based on the instructions, do sketch. include library file, and a zip file, and then we'll navigate. And again, these instructions are on the site. I know you probably can't see this very well. Let's go ahead and just do this. Okay. Okay. Libraries added. Library added to the libraries. All right. So we'll go ahead and do the compile test to verify. And done compiling. And you gotta love the Mega. 8% of program storage was only 8% of the storage was used for program space, and only 12% of the local variables. And so there we go with that. Now what I'll do is do the upload. And if everything works, there we go. And just to reboot it there so we can capture the splash screen. Okay, so looks like we're working. And if I power up the board, or the radio itself, I have it in I have two separate power supplies, one from the computer, of course, here. And now we should have, and I need to provide, reboot it here, so sorry. Okay, so it's working. I will go through the details of the actual front panel operations in a future video, but just want to get this done. And now we know our second version of the front panel is working, and then I can now do additional development work. I want to try to include a GPS module for a real-time clock synchronized to GPS satellites, and also maybe do some work with this OLED display. And I have a color TFT touchscreen here that I may or may not do more work. But anyway, with this proto board layout now gives me the option of doing that versus this one, which was pretty much packed solid. I couldn't do a whole lot more with this. And what I'll do is I'll probably reconfigure this one as well, and eventually build this into a standalone finished board. Oh, by the way, I've always had questions about how long the I to C bus can be from the Arduino over to the SI5351. And if you look at this here, the two twisted pair, the green and white and blue and white, are the I to C data and clock lines going from the Arduino side of the project. And I guess that's about an 18-inch run over those two twisted pair. They end up on the SI-5351 module here. And what I've done, I've left them physically plugged in here, but I've installed an AB switch, which adds another 12 or 20 inches of line. And then they come down these two wires here, this blue and white wire, down to the new proto board to this Arduino's I to C. So as you can see, it's I guess it's a good 3 foot of wire there. So it looks like there's, at least in my particular case, I don't need to be concerned that my Arduino may be on a control front panel and then the actual SI-5351 may be buried deeper into the actual RF deck. And what I do is I come off this 5351 with 2 coax cables, which then drop it down to the mixer board and then to the balanced modulator product detector. Oop, I'm looking at the wrong thing here. So there you have it. Thanks for watching. N3FJZ73, everyone.